Hey guys, so in this video we're going to look at how to interpret and create box plots, which is another term used for a box and whisker. So the first quartile is the median of the lower half of data. It is the 25th percentile. In your calculator, you're going to see it noted with a Q1. The second quartile is the same exact thing as the median, which is the median of this entire set of data. It represents the 50th percentile. In the calculator, you would see MED for median. The third quartile is just the median of the upper half of the data, and it is the 75th percentile. And in your calculator, you would see Q3, which represents the third quartile, and your interquartile range, or your IQR, is the difference between the third and first quartiles. This you're going to actually need to memorize. That IQR is equal to Q3 minus Q1. So now let's look at the parts of a box plot. Over here, this line right here represents your minimum value or the lowest value, while all the way on the other side is your maximum value. Now looking at the breakdown of the box part, we have our Q1 or our lower quartile. The second line represents our median, or our Q2. And then that third line is Q3, which is our upper quartile. If we're looking at this line, our minimum, it is 0% of the data, while our max would represent 100% of our data. From our minimum to Q1, we have 25% of our overall data. From Q1 to median is another 25%. From the median to Q3 is another 25%. And then Q3 to the max is the last 25%. It should make sense that we're breaking them into quartiles. Quart comes from 4. So if we were looking at the overall set of data though, the minimum to Q1 is 25%. The minimum to the median is 50%. Minimum to Q3 would represent 75%. And then the minimum to max is 100% of the data. So for this first example, we're going to create a box and whisker or a box plot for the following information. So to save time, I already inputted all those numbers into our calculator. So I'm going to go to Stat, Edit. Again, I typed in all those numbers. From here, I hit Stat, Calc, and Option 1 for one variable statistics. And then I'm going to keep scrolling down on my screen until I see the minimum, Q1, median, Q3, and max, which are the 5 numbers that we need to complete the box plot. So once you locate those numbers, you're just going to write down the values that you see. So the minimum we had 18, Q1 was a 23, the median is a 25, Q3 was 29, and then the max was 30. Once you have those 5 numbers, you're going to label your number line. And again, I already labeled it just to save time in the video. And we're going to locate the 5 numbers that we need. Our minimum was 18. The Q1 is 23. The median is 25. Q3 is 29. And then the max is 30. So we're going to put a box from Q1 to Q3, and then we're going to extend the whisker part from the minimum to Q1 and then Q3 to the max. And then some follow-up questions. What is the range? The range is our max minus the min. So the largest number in our set is 30 minus the smallest number, which is 18, for a range of 12. And then for the next question, it says the interquartile range. We must remember our IQR is Q3 minus Q1. So we're going to take that upper quartile of 29 and subtract the lower quartile, which is 23, to get an IQR of 6. The next thing that we're going to look at is determining outliers from a set of points using the IQR. So an outlier is a value that lies outside most of the other values in a data set. So in order to figure out what exactly an outlier is, we need to figure out the following information. So we need to first identify the Q1, the first quartile, identify the third quartile, the Q3, figure out what the IQR is, and then use the following equation. Q1 minus 1.5 times IQR. So we're going to look at the numbers from whatever number we get when we use that portion to whatever number we get when we take Q3 and add it to 1.5 times the IQR. Any number that doesn't fall between that from and to, anything outside that range, is considered an outlier. So we're going to look at an example in the following problem. So at this time, what I want you to do is take all those numbers, those 16 numbers, type them into your edit list. And then what I want you to do is figure out the minimum Q1, median Q3, and maximum. So if you can, just pause the video at this time. You should have gotten the minimum was 0, Q1 as 1.25, the median as 1.75, Q3 as 2.5, and then your maximum as 8. So for part B, it says, what is the interquartile range for this data distribution? So what you want to do, again for IQR, is take your third quartile and subtract your first quartile. So I'm going to take 2.5 minus 1.25. We're going to get 1.25. The second part of the question is asking what percent of the students fall into this interval. So we're talking about the interval of Q3 to Q1. Just a reminder that Q3 was 75% of the data and Q1 was 25% of the data. So when I subtract that, that is about 50% of the students that fall into that interval. And then we want to create a box plot using the 5-number summary. So what we want to do is break up our number line into even components. So I'm going to pause the video and do that. Okay, so from here we're just going to take those 5 numbers and create lines. So our minimum was 0. Q1 was 1.25. The median is 1.75. Q3 was 2.5, and then our maximum is 8. So we're going to create a little box from Q1 to Q3, connect our minimum to Q1, Q3 to the maximum. For part D, would you consider the data distribution to be skewed? So our distribution we did look at from the previous lesson. So we're talking about, is it normal, equally distributed? Is it skewed left or skewed right? So for this example, we should see that it's skewed right. Skewed right just means there's an outlier to the right that's pulling or stretching our box plot further. So it's skewed right because most of the data is to the left. Skewing it to the right or stretching it to the right is just showing you that there is an outlier that exists. For part E, it says estimate the typical number of hours that a student does homework each night. Why did you choose this number? So usually we want to use either the median or the mean to describe a typical number. We usually use the mean if there is no outlier, or we would use a median if there is an outlier. So for this problem, because it is skewed to the right, the best typical number to use would be our 1.75, which was our median. And the reason why we chose this number was because the student that spends 8 hours a night, which is our obvious outlier, is bringing up the average. So we would have to use the median. And then for part F, it says, do any data points represent an outlier? And we must show our work to prove that it is an outlier. So like we said earlier, there is a formula that you could use to determine if there is an outlier, and I did write it down when I paused the video. So you're going to take your Q1 value, which we did state earlier was 1.25, and we're going to subtract 1.5 times the IQR, which we said was 1.25. Then we're going to take the Q3, which is 2.5, and we're going to add it to 1.5 times our IQR, our interquartile range, which is 1.25. So I'm going to take all of this and type it into the calculator exactly how I see it. 1.25 minus 1.5 times 1.25. So negative 0.625. And now I'm going to take the right-hand side, 2.5 times, 2.5 plus, so Q3 plus 1.5 times our IQR. And then hit enter, 4.375. So now I need to look at all my data points. So I'm going to scroll up and I'm going to look at all these numbers listed right here. And I want to identify any point that does not fall between negative 0.625 and 4.375. So all of these numbers except for 8 fall between these numbers. Therefore, the outlier does exist, and the outlier is the number 8.